Okay, today's lecture is going to be about wind power. So up to now, we've discussed a couple things. The financial and economic basics of the electric power industry, so how utilities get money to build infrastructure like power plants. How do they decide what type of power plant to build when they do get the money to build the infrastructure? How do they operate the power plants optimally once they've built them? And then how do market prices for electricity go up and down? We also spent some time talking about the history of the electric power industry. We talked about how the electricity business evolved from its early days to the system we have now, right? So the importance of the decision to go with AC versus DC power systems, the importance of the decision to treat the electricity industry as a regulated monopoly. We talked about the difference between regulated monopolies and deregulated markets and how the push for market deregulation came about, really starting in the 1970s and going through the early 2000s. And we talked about the difference between wholesale electricity and retail electricity. Then we spent a couple lectures going inside an electric power utility. We talked about how utilities make decisions about long-term planning, how they project future potential increases in demand and make decisions about how to meet those increases in demand. We talked about, from an operational standpoint, how utilities and system operators decide which types of power plants to use and when in order to meet electricity demand that's constantly fluctuating. And then we also talked about how utilities set prices for retail consumers. Along the way, we spent some time as well doing sort of a survey of conventional generation technologies. So we would include in that group coal, natural gas, nuclear, and hydropower. These are the types of power plants that we really relied on exclusively for the first 70, 80, 90 years of the history of the electric power industry. And we talked about their pros and cons, both from an operational, engineering, and economic standpoint, as well as some of the broader life cycle environmental impacts that are involved when you rely on coal, natural gas, nuclear, and hydropower. So if it were 2005, that would really be the end of the class. Knowing about how the electric power industry works from both a financial and economic standpoint, how power systems are operated on a day-to-day, hourly basis, what generation technologies are involved. Really, until 2005, it was just coal, nuclear, natural gas, and hydropower. But lucky for us, that's not the end of the story. So we're going to start talking about how the grid is changing, in particular how the makeup of the generation mix is changing. And a lot of that is trending towards increased dependency on variable renewable energy, including wind power. So in a way, it's appropriate that it took basically 2/3 of this course to get to this point. The electricity industry is changing, but it's taken a really long time. If you think about where we are today, which is increasing in our dependency on renewable energy fairly quickly, but it's really taken a very long time for us to get to this point where we are making progress in terms of reducing the carbon intensity of the grid. And the reality is, despite the recent progress we see in terms of increased uptake of renewable energy, things aren't moving quite as quickly as we'd hope, especially if our end goal is to mitigate the worst impacts of climate change. And so that's going to be kind of a consistent theme throughout the rest of the lectures as well. So we're talking about wind power today. So the three quasi-final exam questions for today are: what are the economic advantages and environmental benefits of wind power? What are the challenges associated with integrating wind in electric power systems? And what are the impacts of wind integration on electricity markets?